Okay, students, so we just completed scalar multiplication, and then we completed using the order of two matrices to determine if the matrices could be multiplied. So let's do this example here. So we have these two matrices, 2, 5, 6, 3 and 2, 1, 8, 4, and we want to see if we can multiply them. So just a brief recap. The order of the first matrix is 1, 2 rows by 1, 2 columns, 2 by 2. The order of the second matrix is the same, 2 by 2. Once we see that these numbers here are the same, what that means? That the columns of the first matrix is equal to the rows of the second matrix. Then the answer is yes, they can be multiplied. So let's continue into actually multiplying these matrices. Okay, so it's the same two matrices, 2, 5, 6, 3, 2, 1, 8, 4. We previously determined that they can be multiplied, so let's do it. So what is the method? The method is simply we multiply rows of the first by columns of the second, the first by the first, the second by the second, the third by the third, and so forth, and then add. So what does all of that mean? So as I said, we multiply rows by columns. The first by the first, 2 by 2, and we add now 5 by 8. So let's go on. We're going to multiply the same row by the second column. The first by the first, 2 by 1, plus 5 by 4. Now we can see that there are no more columns to multiply this row by, so we're going to move on to the second row. So we're going to multiply this row by the first column. So we're going to have the first by the first, 6 by 2 plus 3 by 8. And then we're going on to now the second row by the second column. The first by the first, 6 by 1 plus 3 by 4. Now we're going to simplify. 2 2s are 4. 5 by 8 is 40. 2 by 1 is 2. 5 by 4 is 20. 6 by 2 is 12. 3 by 8 is 24. 6 by 1 is 6. Plus 3 by 4 is 12. Therefore, the answer is 44, 22, 36, and 18. So, a brief recap. When we're multiplying matrices, we multiply rows by columns and then add the first by the first and the second by the second.